Well, hello everyone in person online, and welcome to the Water Resource Institute Spring Seminar Series, Catamounts, Catalyzing Change. And during the seminar series, we're highlighting UVM alumni that focus on impactful water work across the nation. The series will dive into their current work as well as how they navigated their path from UVM to their current career. My name is Anna Schmidt, and I'm a graduate student here at the University of Vermont in the Rubenstein Ecosystem Science Laboratory. And I'm very excited to introduce today's talk by Ben and Ismar Biberovic, entitled Advancing Water Resources Management Through Applied Aquatic Ecology. So Ben Block is an aquatic ecologist and data analyst with Tetra Tech and has 8 years of experience in aquatic research. He primarily focuses on Clean Water Act support projects, such as the development of numeric biocriteria as indicators of human disturbance, as well as stressor identification of impaired waters. His understanding of stressor response relationships is applied to areas such as water quality and biological criteria establishment, non-point source pollution assessments, stressor identification, site classification, and ecological assessment. On a variety of projects, he provides technical assistance, including data compilation and quality control, geographic information system analyses, data analyses, including R and R Shiny, and technical and non-technical writing. And as of 2026, he leads the ecological analytics and model group's ecology subgroup. And Ismar Biberovic is an aquatic ecologist and data analyst with Tetra Tech, with 7 years of experience supporting aquatic research and Clean Water Act programs across the U.S. His work focuses on biological assessment, nutrient and stressor response analysis, and the development and evaluation of biological and water quality indicators using diatoms, macroinvertebrates, and long-term monitoring data. He applies these approaches to support nutrient and biological criteria development, stressor identification, impaired waters assessments, and independent technical reviews of water quality monitoring programs. Across a range of projects, Ismar provides technical support through large dataset compilation and QA/QC review, GIS and geospatial analyses, advanced statistical modeling in R, and clear technical and non-technical writing to inform state, tribal, and federal water quality decision-making. So this talk will be about 30 minutes with 15 minutes of Q&A at the end. So please hold your questions until the end, and welcome to our remote guests. If you're joining via Zoom, you can enter your questions into the chat box at any time during the presentation. And I will now turn the floor over to our speakers. Thank you.
Awesome. Yeah, thank you. Yes. All right. So we before we came here, before we started preparing this PowerPoint, I actually stressfully called Hannah and I said, so what do we have to talk about here? What are people interested in? And then Ben and I got together and we came up with a talk outline that we thought would be useful for everyone to hear, and hopefully informative enough. It's not specific, we'll mention some of the technical project stuff we work on, but for the most part, what we came up with is just giving an overview of what our job looks like and how we got there. And this is, I'll use remote, a little too sensitive, but anyway, we came up with a brief introductions of ourselves, how we managed to get through grad school, start working for Tetra Tech, who or what Tetra Tech is, talk specifically about the group we're a part of, and then highlight some of the projects we're currently working on, and the projects we finished, which are, just sort of a glimpse into the world of consulting, and then talk about the work-life balance for some of us and balance for others. I'm the imbalance part, there's the balance part, but anyway, yeah. And please know that, we'll be talking, this is from what I've seen, this is the first dual presentation as part of the WRI. So we'll try to complement each other's comments on some of these slides and whatnot. So this was all intended. So who am I, right? I am not the International Society of Magnetic Resonance or the Institute of Marine Sciences or any other acronyms out there. I'm just an individual who is confusingly named And this is coming from the fact that my boss, for some reason, tried to look up a few months ago, look up the meaning of my name. And this is what he found. And then he came back to me and he said, did you know there was an Institute of Marine Science that has an acronym of your name? And I thought that was pretty cool, but at the same time, I wanted to clarify that I'm a real person and not any of these things. So I'm a person who immigrated here in 2015. I started my journey at the CCV here in Winooski in the environmental sciences program. And after a year, I had to get grades that were good enough to be transferred to UVM because UVM wouldn't accept my diploma from Sarajevo. So I ended up transferring to UVM, also into the environmental sciences field. Dr. Clay Williams was my undergrad advisor. I worked with him closely, and the idea behind me starting environmental sciences was to focus more on forestry, learn about trees. I was always into hiking and trees. And then Clay was really good at persuading me into liking lakes. And the more I learned about lakes and the more I talked to him and ultimately Mindy Morales, I started liking lakes and started disliking trees a little more. So here I am as an aquatic ecologist. So when I was an undergrad, again, I got connected with Clay Williams, who was also my advisor, and then we started talking about an undergrad project. And we landed on the dissolved organic matter in lakes. And, this was my first exposure to any sort of statistical analysis, really using R. I learned R then, and then started coding, started just thinking, reading these papers, thinking about what I can research in terms of carbon in lakes, and did this undergrad research project on the drivers of dissolved organic matter bioavailability in lakes. And in the Vermont Limnology Lab. So as an undergrad, I joined the Vermont Limnology Lab, working with Mindy Morales, who also guided me through this entire process. Ultimately, I was offered a sort of a graduate position at the lab, but it had nothing to do with dissolved organic matter. It was a paleolimnology focused grad position where we were looking at the relative change of nutrients in inland Vermont lakes, and a few other things. So I was there for, in total through the undergrad and graduate school, about 4 years working at the lab, helping out with dishes. I'm really good at doing dishes, lab dishes, if anyone needs help, and a few other things in the lab, but I am proud of my dish cleaning skills. And then now I work for Tetra Tech as aquatic ecologist, and I've been with them since June of 2023. And like we mentioned in the beginning, a lot of my work focuses on environment assessment, biology, ecology. We really like the living things. And, obviously there's a lot of intersect there with nutrients, hydrology, and all these other components.
And Ismar, this is like a
Okay.
But yeah, my journey is somewhat similar, but without the international, relocation component. But I did grow up in northern Wisconsin and went to the University of Minnesota Duluth for my undergraduate degree. And I do have some photos here. The let's see here, actually 2 in the middle, I suppose, are from time in undergrad on Lake Superior and other lakes in Minnesota, Wisconsin area. And I had a lot of random work in research as an undergrad because I kind of bounced around labs. I didn't work with one professor for every year I was in undergrad. So the center photos working with Don Brandstrader and other colleagues, Andy Bramberg, collecting sediment cores from Mille Lacs Lake in Minnesota. That was a pretty transformative process of learning about winter limnology, and that was particularly focused on looking when spiny water flea first invaded that lake because the spines stay in the sediment. Anyways, then I got into winter limnology with Ted Ozerski, who is also at UMD, and basically had one paper that he and a bunch of 50 other people published with, and I just started going down that list of whose lab should I go to for grad school, and then found Jason Stockwell here, and I was like, oh, that lab looks pretty cool, and I think you had just got your new website from one of the other students, and I was like, this looks pretty sweet. So that's how I ended up in Vermont working on winter limnology, and that kind of transitioned more into winter fish ecology. So I have a few pictures here of us ice fishing, catching a bunch of yellow perch. Here are 2 of the undergraduate researchers that I worked with, and that was basically catching fish. This was an eel. We just caught that as bycatch. That wasn't purposeful. But either way, catching eels and then dissecting the actual target species for what they were eating. And then I graduated with my master's in March of 2020, which was an awesome time. to graduate. But thankfully, on my birthday, I got interviewed to work at Tetra Tech, so it was a nice birthday surprise. And a month later, I ended up starting, and I've been there now almost 6 years to the day, and have had a lot of cool experience as also starting as Ismar as an ecologist and data analyst. Okay, so now we're gonna give you some overview of like what Tetra Tech is. And we're gonna not really make this a marketing thing, so we're gonna try to skim over some of
The
this
slides
stuff.
are from the marketing department, though.
Yes. But we wanna just like emphasize like how silly big it is. So basically Tetra Tech's a giant consulting firm, and the way consulting firms often work is that they acquire more consulting firms. So at this point, in the way that you all can kind of think about this is that Tetra Tech is like a university. You all are here obviously studying a very similar field. I want you to think about what the art people are doing right now, or the like linguistics people. You probably have no clue who those people are, and that's similar to us. We have something like 30,000 employees at this point, and we don't know what they do. But there's always something new. We have this internet, and we find out, oh man, they're doing something in like Uganda, creating like a new hydro plant or something. So it's always kind of crazy, but basically we have it split up into a government services group and a commercial industry group. And so we're in the government services group, obviously, whereas there's a whole other group focusing on other components of engineering, architecture, that type of stuff. Do you have anything to add to that? No? Cool. And yeah, to reemphasize that focus, Tetra Tech is known for its work in water resources, but also does a lot of other things like environmental work, power engineering. We now have a high performance building company. So that's like building LEED certified buildings. There's all sorts of things like for climate, and have a pretty active business in disaster and emergency management. So when it like flooding happened in Montpelier, or there's a hurricane, there's oftentimes a Tetra Tech outfit that goes there and kind of handles the remediation cleanup side of things.
Yeah, we're so in Tetra Tech, both Ben and I, and maybe a smaller group of people are part of this section that we refer to as water. And this water section does a lot of different work. We can't even tell you what geotechnical engineers do for the most part, right? But we typically interact with some of these other groups. We're in the biology, ecology realm. There's limnology, toxicology, hydrology, and hydraulics. So within this larger group of water, there are much smaller groups that do very skill-specific things here. So again, we're in this group, although on our daily basis or on a weekly basis, we may interact with other 4 or 5 people from the group, and we typically, don't interact with electrical engineers or something like that, unless there are some very specific projects. And I don't know if there's anything else you want to add. And then these are just the locations that we have of this water group. And we're here in Montpelier, Vermont. So our main office is Fairfax, Virginia. Recently I've had a project with that office from Seattle, but typically we stay within the boundaries of our offices, even though we will do international work. Every water office tends to specialize in a specific thing or two. So we'll often have to collaborate with other offices to either get a grant or work on a single project. But then we have 443 employees, 25 offices. This is just in the water section. We're working almost on 2,000 projects and almost 600 clients. The largest ongoing funded contract is $35 million. I'll tell you, this is not a science-related contract, probably engineering or something. We definitely would not get a grant this big to do what we do. Yeah, but again, out of 443 people, there are only so many people you can interact with sort of on a monthly basis, and where your interests and your specialties intersect. And for us, that is a smaller group of about 20 people or so. And then go ahead.
So like we alluded to earlier, so we're kind of doing this like funneling effect. But we started with Tetra Tech, and now we have this water, which is what in parlance is like an operating unit, and then we have what we've dubbed the ecological analytics and modeling group, for EAM. And so we're both part of this. It's about 15 of us, and we have a fair amount of diverse specialty. We have now 3 subgroups. Both Ismar and I are in the ecology subgroup that I lead. but then there is a geospatial subgroup and a modeling subgroup. So they all kind of overlap in some cases and are sometimes unique and distinct. Like we do a lot of biological assessment and ecological index development, but then there's a lot of general geospatial data science. So that's obviously context dependent. We use GIS for a lot of our projects. But then if you go to the next slide, Ismar, there's all sorts of stuff, but actually there's two people we recognize that are in the room on a nice public. This was a sediment accumulation rate project with the EPA, and so that was a really neat one that I was to stick in. But anything in the Clean Water Act realm, climate change, then we've also gotten into the more like stricter data science realm where we're doing a lot of like coding and modeling, and then we both maybe struggle to describe it as much because we're not like environmental engineers, but there's a subgroup that does a lot of like HEC-RAS modeling and different hydrologic models for different climates, and so that's oftentimes related to TMDLs, which are total maximum daily load populations, and so that's a lot of modeling, but we have quite a bit of things that we do, and it's a cool group because then we're all learning from one another. While we don't have that expertise, we can rely on the others.
Yeah.
Do you have anything to add to
No,
that?
no, that's it.
Cool. So I guess one thing to like frame the projects that we're the remainder of it will be like projects that Ismar and I are highlighting, and what I wanted to do is somewhat frame that into like why we're doing a lot of these projects, and it largely stems from the Clean Water Act. And there's this one sentence that basically says that it aims to prevent and reduce pollution in the nation's waters to restore and maintain the chemical, physical, and biological integrity of the nation's waters. And most of our projects have that theme in mind, just like defining that or addressing that sentence, because we could break that down into, obviously, you can imagine what chemical integrity is as far as like water pollutants. There's physical pollutants, something like erosion or some habitat degradation, and then biological integrity is similar in that it relates to the biology of these systems. And so the goal of the Clean Water Act is to protect the integrity of all of that, and so we support a lot of state agencies that's their primary mission. So, like Ismar alluded to, one of them is one of the large foci of our office that's been for the past 5 years, and our supervisor, Ben Jessup, who's now retired, or at least semi-retired, his focus for the majority of his career was on the development of these IBIs, or indices of biotic integrity. And they're a numeric, a multimetric compilation of different values that summarize biological community data in a way that you compare that between reference conditions and your ambient conditions. And so in this example down in the right of this graph here, we just have one of those metrics. This is the number of taxa that have a specific attribute, and it's expected to increase in value with increased stress. And so this is just a box plot example of that, but you have these reference values that are something below 2.5, and then the rest are the stress categories, which are the ones in orange, are higher. And so we kind of differentiate, we try to identify which metrics are performing quite well. So the reason why I explain what these are is because we have like basically 3 projects we're going to highlight that are uniquely different, but they all are IBI development projects. So the one that I lead with the Massachusetts Department of Environmental Protection, I've been working on this basically since I got to Tetra Tech. It's been a long process, but it might be over sometime next year. And this one's pretty cool because it focuses on stream diatoms as indicators of pollution. And so we initially started in 2021 with trying to compile a regional data set, primarily from like Connecticut and Maine and Rhode Island, and see if we could just create an index and then have them go out and sample and try to apply it to their streams. That obviously didn't work because we've found, even though that like the EPA will oftentimes try to do like a full regional analysis, once you dig down into like the state level, there's so much variability that it's better to create a model for your specific area. So, and this is partially why Ismar was hired, is to help with this project, in that we've spent the last 4 summers going to Massachusetts and collecting stream diatoms. It's a lot of scrubbing rocks on the side of a really pretty stream or a really gross stream near Boston. So we usually try to do the growth streams first in like, it's like a week of sampling. So we'll go to the growth streams first and then end in the nice Berkshires. And it's pretty zen. It's just growing rocks. But anyways, so we've been through 4 years to 120 different sites in the state. And so that's what this map here is on the bottom right. And they're color coded from red being bad, green being good. So sorry if you have anybody's color blindness. I recognize I didn't actually deal with that. But either way, that's unimportant. And so a lot of the work that we've done and I've done with this project and kind of emphasizing more of like the skill sets that are involved in that is not only visiting 120 sites and trying to figure out where to stay every night and coordinating things amongst our team ourselves, about coordinating with a production laboratory to take our water chemistry samples on a daily basis, and then sending samples. We subsampled the diatoms to actually send one subsample to a taxonomist and one to UNH for DNA metabarcoding. And so the cool part about this project is that we're going to have this paired DNA and microscopy data set and try to build indices using the two data sets and see how those shake out, because that's where a lot of the DNA metabarcoding is focused on right now, is diatoms. And so it's a pretty cool aspect of this project, why we wanted to highlight it. And so, yeah, I guess I missed this part, but a lot of this is data QC right now, because there's no analysis going on. That's actually going to start in July after this last phase of work, but it's making sure data look right, summarizing it, QCing it in R, putting it in databases, having lots of calls. We're having a reconciliation call with the two taxonomists that we work with on Friday. So it's quite a bit, but I think that's basically all I wanted to talk about there. So I'll pass it back to Ismar.
Yeah, I ended up working on a few projects that challenged what I knew, although my skills and knowledge translated pretty readily, it seems like. So one of the projects we got shortly after I was hired was to develop the Long Island Sound IBI. So it's coastal waters. I only really explicitly worked in lakes during my graduate degree, and also once I was hired by Tetra Tech. So this is something that I think challenged me, made me read a lot of papers, and I thoroughly enjoyed it. And I enjoyed it for a few reasons. I'm not going to go necessarily through the bullet points, but the idea of working in Long Island Sound is the fact that, essentially everything is one big watershed for the most part. Embayments aren't streams, so quantifying stress in embayments is not the same as quantifying stress in a given stream segment, because you know exactly where the water is coming from. Whereas here you have high tide, low tide, the water sort of moves unpredictably for the most part, even though you obviously have some other freshwater inputs from the land. So there were a few challenges that we had that aren't necessarily typical of freshwater streams. And one of those challenges were trying to quantify stress, and we had to get creative with that. And one of the efforts we did was trying to go through the hot watersheds and combine them in a way in which they make sense surrounding these embayments and the areas from which macroinvertebrate samples were collected. Another issue we had was the fact that this project was funded by the Connecticut Department of Energy and Environmental Protection, and they only had about 70 samples, which we deemed insufficient to develop an IBI. So we needed to expand our area of interest, and this is what we expanded it to, from Lytton Bay to Buzzards Bay. But when one is expanding this area, we need to make sure that the communities we are likely to encounter there are still representative of communities for the area that we're interested in. In this case, the focal area was the Connecticut shore. So then we had a lot of calls and a lot of thinking about what's appropriate to include, and this is what we ultimately arrived to. And then there's this whole argument of what is an embayment. And in Long Island Sound, at least, nobody seems to know exactly what an embayment is. So we had to get really creative as to what we defined as embayments. We came up with an approach based on the depth and distance from shore, rather than going through each one of the almost 80 embayments that Connecticut has, or that they designated as embayments, and the rest of this area. And again, some of these organisms, some of their names you've never come across, you're not exactly sure what they mean. There aren't that many macroinvertebrate indices of biotic integrity in coastal systems. So you need to do a lot of digging to see, which parts of community respond to what kind of stress. And I will say IBIs are typically not stressor specific. They sort of give you a better, just like a more general condition of biological health. Ultimately, we developed an index for them, and we had to combine their data with the National Coastal Condition Assessment data. But what we also did, what I found really interesting is we developed two story maps. One story map was purely technical for people who are well steeped in science and know what they're doing with these. And another story map was non-technical, meaning that anybody can, interact with it. Both of them were made really interactive, but people can understand it and not necessarily be scientists. And then we also created an R Markdown script for them where they can simply, for Connecticut Deep Staff, where they can, if they collect data next year or the year after, they can simply input those data into the script and it will do everything else for them. All they have to do is compile the data, get the data sets. So that was the component I really enjoyed, in addition to the fact that this was my first experience working with any type of marine systems. And now I'm working on another one in the city of Naples, Florida, regarding macroinvertebrates and fish and looking at biological trends over time, which was kind of cool because this was my introduction to those kinds of systems. And then we have another one, like Ben said, some of these are pretty unique, and this one is unique because we're developing an IBI for large rivers. And the reason large rivers are so special, not just in Oklahoma, but everywhere, is because they integrate stressors over huge watersheds. What I have here is just a plot of what we have for sites there. We're still working on trying to select the sites that are truly large water. The Oklahoma folks told us that these are non-wadable sites. We're trying to get those to actually represent large rivers and not necessarily just non-wadable rivers. And as you can see, we're working with watersheds that are anywhere from 100 square miles to 50,000 square miles and more. And the issue with these is that there are so many various stressors and factors interacting in these watersheds and in these streams that may be driving what you're seeing for macroinvertebrate and fish communities and streams, and we're trying to navigate that. So this project is still in progress, and we're nowhere near done, by the way. But one component we're stuck on right now and trying to figure out is how do you quantify stress? And it turns out there really isn't that much literature giving you any sort of guidance on how to quantify stress in large rivers and large watersheds. There are these specific parts that we're finding that, what we want to know is where agriculture matters. Does it really matter if agriculture is 5,000 kilometers away? Or is there something about its scale and its proximity to these sites of interest that we can tell? And again, this is not just agriculture. This is also stream size, stream shape, meandering, all those kinds of things. So that's something we've been dealing with in Oklahoma. And what we're trying to do is also set this precedence of developing these, because it turns out there's really only a handful of these globally and maybe 2 or 3 of these nationally that have been developed. And the last one I found was from 2009. So really there has been no work done by EPA to sort of push forward this large river IBI and, specifically to talk about the disturbance gradient of large rivers. So we've been meeting with EPA folks regularly, a group of the EPA biocriteria group, to make sure that we're doing everything that they expect and to get also to get their input, because we do intend they will continue using our approach and our methods once the project ends.
Awesome. So I think now I have 2 slides that kind of shift gears, and I wanted to show projects that are really novel to me and would probably be novel to most folks coming out of UVM or another water resources program, but are kind of integral to, again, our whole Clean Water Act theme. And one of those is this project I'm working on with the state of Massachusetts, which is to revise and update their consolidated assessment and listing methodology guidance document. And so there's a giant document, we call them calms. And they're not calm because they're like 170 pages long. So that's pretty intense. But basically, Massachusetts is kind of on the forefront in that they want to make, sorry, I should back up. These documents are really to understand how they can use data to make assessment and listing decisions. So that's in the process of regulatory parlance. You assess a water body by using data that you collect from it and make a decision as to whether or not it's polluted or not polluted. And there's a lot more regulatory nuance to that. That doesn't need to be concerned, but if it is deemed to be polluted, you would list that on a special list, and that goes to the EPA, and that triggers all sorts of regulatory things, like it's gonna be cleaned up. So for example, Lake Champlain has a TMDL. It was originally listed for phosphorus way back in the day, and that's kind of the outcome of it, is a TMDL. And so this is the front end of that, is each state has basically a guidance document that says, okay, the practitioners, the state staff, how do they go about when they go and collect a water sample, or they collect a fish sample, or they receive data, how do they handle that? Anyways, that's why it turns into 170 pages, because it describes every possible thing you could possibly sample and every type of water body. Anyways, Massachusetts's was a mess, and frankly, they're not alone in that. It's this really giant document, but it was cool because we're working with them to revise that. So I worked really closely with a technical editor that we have on staff. She has an environmental science degree, but somehow has become a technical editor over time. She enjoys it so much, but we carved this out and reformatted it with the state staff to be really quote unquote user friendly, where like the beginning is more gauged towards probably you all knowing science. Is not like intended to be for something where it's my mom being able to read it. But the second phase of this was then to get into key components of it, like how do you evaluate habitat or hydrology independently and do that consistently, or how do you, there's some additional components of sampling for temperature and dissolved oxygen using continuous sensors, because over time, obviously, they've transitioned from having the Winkler test for DO, and now you have a DO sensor that stays out for 3 months. There's different analyses you can do with that. But I wanted to highlight this one because I think it involves a lot of stuff that we learn at UVM or other graduate programs that are then directly applied, but it has this really nuanced take to it, a lot of research into how things are going, but that's then maybe comparing and contrasting to other states and what they're doing, as well as, proficient writing, technical editing, that type of stuff. And then this project especially has been a lot of communication directly with the client, discussing how we go about handling this, because they're kind of on the forefront. So when there's, like Ismar alluded to with the Oklahoma work, if there's no guidance that somebody else has done, we're kind of guiding that process forward. And so that was a really cool project, and it's still ongoing. It's almost wrapping up. And on the other side is our R skills, and I would say that both Ismar and I learned quite a bit of R in grad school, but it really kicked into overdrive having to learn R for our jobs. We basically use it, I don't know, I probably use it nearly every day. And this project is specifically similar to the last slide I showed, but now on the actual analysis component. A lot of this has been done in Excel, and so you can imagine these poor souls of each state having to analyze every 2 years all of the last 5 years of data and make decisions upon them for every water body in the state that they've ever visited over that time period. So that could be hundreds of water bodies and thousands of data points. And so this was weeks worth of work for usually individuals, if not small teams of a few people. And so this project is working with the New Mexico Environment Department, and they contracted us to build an R package to help them analyze these data. So all of the work that they needed to do in Excel that would take a couple of weeks or maybe a little bit less, that turned into minutes of work. And so the R package basically now, it takes the data that comes out of their database, they plug in the data, it QCs it for them, and then it analyzes all of it in one script, basically does it in about a minute. But I wanted to demonstrate this because I think it really emphasizes that we're really looking for advanced coding skills at this point. It's basically a must. And it is useful to understand like water quality standards and the calm work. And the other cool component was just teaching them how to use R more proficiently, and the excitement that they had that we saved them hundreds of hours of work each assessment cycle. And so that was, I think, pretty sweet. And I've really enjoyed working in R, and I think Ismar does too. It makes pretty cool graphs.
Sometimes.
Yeah. But yeah, that was a really cool one, and just to demonstrate that. And so I think, yeah, the last
Yeah.
presentations.
Yeah, so we sort of wanted to bring this here locally. We do have another project in Lake Champlain Basin. But there's this project we're working on with Lake Champlain Basin Program and Lake Champlain Committee, where we're essentially looking for benthic cyanobacteria in Lake Champlain and inland lakes. And what we thoroughly enjoyed with this project was still continue to enjoy because the project is ongoing still until 2027. Is this work that we're doing with volunteers. So we are essentially leveraging the existing volunteer network here in Lake Champlain Basin and trying to tap into their potential of monitoring for things that we want to monitor for. So instead of an individual going to 200 different sites over the course of the season, we're trying to leverage volunteers to take pictures for us and make notes of what they're observing in the water column. And as you can tell, that comes with challenges because volunteers aren't necessarily, trained aquatic ecologists. They're not used to seeing all these various things. But this project specifically just blends the community science with advanced lab analytics. So what we have volunteers do is submit a survey once they come to their site, take a picture, submit a few observations. This was all done through survey 1, 2, 3 of Esri. And once they do that, we're asking them to collect samples. We grab the samples from them, send it to 2 separate labs, one in Florida, the other one in New Jersey for DNA analyses and toxin analyses. Just to quantify risk that may or may not be associated with benthic cyanobacteria in Lake Champlain. We're also developing outreach materials that you can see on the left-hand side there that will and should be used once the project ends in the basin. We continue to revise and update these outreach materials with the pictures that we're getting. One of the challenges here was the fact that we weren't allowed to use just any picture from the net. We had to get specific approval from the image authors. So we're compiling this database of images that we are looking to use for outreach and what we call a photo ID guide for benthic cyanobacteria. So once volunteers go to their sites, they can confidently say that something is or isn't one of the genera in this sort of benthic cyanobacteria realm, and be able to differentiate that from various other algae that look like them but are not. And another thing we did is we sort of tried to come up with this benthic cyanobacteria likelihood map, but this map is more of a here's where we can sample and here's where we should sample and at least get one volunteer to observe the shoreline. And this is something that came up with where these red areas represent boatable sites if volunteers have canoes or kayaks that they can go out and just look for benthic cyanobacteria, and the green areas surrounding the lake. This is just an exit of northern part of Lake Champlain, are the areas where they can observe this from the coast, which is something volunteers typically do. But the nice part also about this project is the fact that it doesn't just necessarily create data, because we're only looking to collect 38 samples or about 40 samples for the project, but it creates this infrastructure and monitoring protocol for the time after this project. And this is something a lot of states do not have. California has one, Utah has one, but specifically for streams and not lakes. So we're trying to be, Lake Champlain Basin Program is trying to be at the forefront of that and have these protocols in place so they can also leverage this network of volunteers to monitor their waters for them. The states, both Vermont, DC, and New York, DC, are also going to use some of the materials we produce as part of their training as well, which is something we're proud of. And then sort of the last part, I don't know if this is a downer or not, we'll see. Is this work-life balance? And I think a lot of people are typically curious about how consultants get paid. And what I can tell you is that our hours, so we're both salaried, but each of our hours has to be charged to a single project. So if I work 5 hours on the Oklahoma IBI, I should charge 5 hours to that particular project today. And there are really 2 types of charges you can have. One is charged to a project. This is from the perspective of Mr. Tetra. One is to the project number. The other one is to everything else, which is considered overhead. And that's not good. You don't want to be charging too many hours to overhead because you're going to get spoken to by your manager. So really, we're always trying to stay what we refer to as utilized. We're trying to work on various projects that can sometimes get challenging. It is yet to become challenging for both Ben and I in these 3 years I've worked with them. Yeah, and especially when you start leading projects too, it's very stressful. I barely slept at all the last 5 days. But anyway, So that's one component of this work-life balance, and then Ben can maybe talk about the rest, and don't mention margaritas then.
Yeah. Yeah, so I mean, I put these are some photos from just my phone that I had, and I was like, okay, well, this is a good work-life balance mix. So walk through it a bit. There's, yes, quite a bit of field work, but we don't have a fancy lab. So like for this diatom project that we're doing in Massachusetts, there was a lot of analyses in a parking lot on the back of a tailgate. And frankly, we went to the same hotel for 4 years in a row because it was this random Marriott hotel that just had this giant parking lot, and they let us set up shop, and nobody ever bothered us about mixing chemicals in the parking lot. And so I was like, these guys are great. But there's that, but then every night we would perhaps get big margaritas to kind of balance out a 12-hour field work day. But that's only like occasionally. So there's some folks that, they want to do field work, and if they don't have field work, then they're not gonna have fun in their job. Because this is my desk setup when I first set it up, and I have 3 monitors, and I sit there basically all day long. And so it's a lot of, R coding and writing, and as you probably guessed, a lot of computer time. And that's great, but also can be really challenging. And the other component here, the other fun one, is that with a project that I didn't mention, I got to go out to Boise, Idaho for a project, and then took a couple days off on the weekend. But that was including hiking up in the Sawtooth Mountains. And so, there's definitely pros and cons. And I think, to as far as point about the billable work, I think one thing that was really great that I felt about transitioning out of grad school is like, I think I really struggled with like maybe promoting myself or trying to show how my research was important. And I know that that can be challenging. And so that I felt, at least it's been very comfortable for me to work in this role where a request for proposal comes out because a client wants this project done. And so long as we put a team together that can reasonably accomplish that in the budget that is usually accompanying that, we get to work on projects that people want to do. And that, I think, is just really great for me, at least. The challenge is then that there are a lot of projects that we do instead of, it'd be great if we got $1 million project and we just like got to do that for a year, but that's not the reality. I think since I've started 6 years ago, I've probably worked on like 30 to 40 projects. And that's from sometimes helping just a little, like a couple hours, to basically doing major tasks, to leading the whole project. And so even right now, I'm managing 6 projects. I only highlighted 3 of the ones I'm currently working on, but there's 3 other ones I'm not, including another basin program project. So there's a lot of irons in the fire, and I think that's something to get used to, but it's probably not too far dissimilar from academia. But you get to work with cool people all across the country, which is also kind of neat, that we get to see stuff in different places, like going to Idaho or working in New Mexico or
That's right.
Long Island Sound. So
Yeah, we have a few projects, and what I like about this job, honestly, there are things that we all dislike a few things about our job. So I dislike a few things, but I won't share them with you, But it's nice in that I also have projects in Utah and Colorado that I'm leading, in Oklahoma and Arkansas and Florida. There are all these systems you have no idea about until you start working in them and talking about aquatic ecology and whatnot, and then you get familiar with their landscape, what their stressors are like, people are there or not, and what their bugs look like, what their diatoms look like, which is always cool, right? So I think it's very nice in that sense. And then also just meeting clients, seeing what they need. And I feel like it's much like my daughters go to daycare, so maybe it's much like their kid. You're always jive with some clients, and other clients are a little more difficult, but you end up working with them anyway. Sometimes getting arguments and whatnot, but it's fun, So it has been really enjoyable, and I've worked as a waiter for 7 years, so I think a lot of those skills translated to this job as well, because you have to be able to deal with a lot of different personalities, and most of these people are really kind and are looking for your help and guidance, which is really cool, because then you're using the knowledge you gained here at Louisville, specifically for us, you in Minnesota, and then translating that to these greater projects that have a true impact, and that you'll be able to see come to life in a year or two. And I think that there's a lot of pleasure or enjoyment that I find in that.
Yeah, I think there's something to be proud of like helping these agencies like do better work in their in their state or in their, we work with tribes too, like
That's
in their
right.
tribal nations, so it's just,
Mhm.
yeah, I think really cool to, kind of impact.
When it comes to tribes, we had a few projects. Again, all of this is planned, this is definitely not conversational. But we had I myself had a project with the Blackfeet tribes from northwestern Montana. There's a knowledge related project I'm working in Idaho on Port Allen Lake with the tribe that has the same name there. So, a lot of these projects are different in that we're working with streams and coastal systems and lakes. And I think one difference there is the fact that when you're a graduate student, when you're in grad school, you focus on one single topic and you become a master at it. Whereas here, you're sort of, you know enough about all of those, but you never necessarily have enough time to become a master in any one of them. So you are constantly becoming familiar with these systems, in a lake in Idaho, right? And this is probably the only time I'll come across this particular lake to do work in it, but it's fun because you're learning a new system and you're starting all over.
Mhm.
So, yeah.
I don't know anything.
No, yeah, okay, well, there we go.
Yeah,
There's our contact info if you have any questions.
yeah, thank you.
Yeah, no pressure for questions. You can also just talk.
Yeah.
I always.
Go ahead.
That was fantastic. Thank you for doing that. I was thinking early on when you were speaking that when I used to teach my general water resources course, I taught about the Clean Water Act. I used to call it the Full Employment Act for water
Yeah.
people.
Yeah.
Here's my question. I feel like you got at this a little bit, Ben, but your comments at the end, Ismar, about the flexibility that you have was interesting. What do each of you think that UVM did really well in training you or in training our students in general? And where do we fall short or could we do a little bit more? I think the two perspectives you're bringing would help us a little bit think about that.
So I think one thing would be like, we probably wouldn't hire anybody that doesn't know how to code in R, at least like decently well at this point.
Do
So
you think UVM's doing that well?
I think I learned a lot, like from other grad students. I didn't explicitly take a course here. So that would be something where it's just like, at this point, data analysis is so far gone. If somebody's showing up with like Excel skills, that it would be challenging. Like if you'd have the exact same person and they had R coding skills, that we'd just hire that person. So that's, I think, one thing that I think I had a learning curve and I was able to like overcome that, but I think Ismar was maybe a bit more prepared than I was, so I don't know how you felt. I felt it was challenging. Yeah.
I will say that we just approved a water data analytics graduate certificate.
Ooh, that
Your
would be
son
good.
has led the development of that.
That's awesome.
That's cool.
Yeah, we both really like art.
Yeah.
Yeah, I mean, I also feel like, not to defend graduate students, but there's only so much you can do and teach, graduate students, because they're stressed as is. But I think one part for me was that collaboration with groups that are, 3, 4, 5, or 6 people. And there are classes, Laura Edling's teaching one of them where, undergrad students particularly are encouraged to interact with, and I was actually a part of that class with the Sventic Center Back There project, encouraged to interact with community partners and work on their projects. And I think that'd be very useful for graduate students as well, to have that experience, but maybe on a higher level, for the duration of your 2-year or 4-year degree, work with a community partner, whoever that may be, whose interests are pertinent to your research, and see how that pans out and work. I don't know, Burlington Parks and Rec, Vermont DC, and they always need help in something. And I think that goes a long way when you start working for a group. And then another thing, again, this can also just be, some people are better organized, but definitely data and file organization, collaborative report writing, technical writing, those kinds of things. I feel like some of those things, obviously I had help from Mindy and she helped tremendously, but would have helped that I had classes that focus specifically on those kinds of, things or components of being a scientist.
And I would say, I mean, Chris, Jason, and I would assume others, your lab and with Ellen, with technical writing has been tremendous. Like that was a huge bonus, I think, coming out of grad school of being able to write well and clearly and describe what I'm doing and what that means. I feel like, you know, even just some other colleagues don't write as well as Ismar and I, and we definitely see it from other publications. And so I think that's just a huge bonus to have as well. It's like that I think UVM is great in that of like improving our writing skills over the course of a couple of years we were here.
And knowledge wise, I think we are really up to par with, you know, everybody else in the group, so we did leave UVM confident in what we've learned. But I always say it would have been nice to, you know, get a better sense what else is out there, to learn more thoroughly about the Clean Water Act. You know, Clean Water, I was an undergrad here, Clean Water Act was mentioned in a few classes, but really only mentioned, you know, 5 minutes of a whole semester class. So Clean Water Act, and just in general, you know, who, I think even now working with Tetra Tech, we have no idea who is willing to fund science. So what do you do with science once you leave and you don't become a consultant? You know, does that mean you have to become a professor, or are there other jobs that you can get? So it'd be nice to, you know, for grad students, I think, to have a sense of what they can do with their degree, except become a consultant or except become a professor or, you know, a researcher. If there aren't other jobs, right?
I was glad you guys touched on the number of projects you do as consultants and utilization. Before I came back to academia, I worked for a much smaller consulting company. And whenever I had new employees, it would kind of, you know, particularly coming out of a master's program or undergrad, it would kind of shock them, like, oh, there's no business development query. And I think that can be a really rough transition for some people, but it seems like you two go pretty well. I'm curious, how do you think universities can improve in preparing students for that? Because if you're a scientist, there's pretty much no way you're not going to be responsible for acquiring your own work at some point, or being part of a team that acquires its work. And I think that's one place where we kind of fall short. So I want to hear your perspectives on training or other opportunities for that.
Yeah, that's tough. So particularly with obtaining our own work, and we both manage projects. There's a few people, well, we both manage, it doesn't matter, but we will rigorously and frequently watch through the RFPs that are posted nationally and see what fits within the realm of our knowledge. And if there's anything that we would be able to, you know, have, I don't know, some sort of an opportunity to gain funds to do research, we go after it. And the way we do that is we try to get people from our group who have the knowledge that is maybe more directly related to that RFP than ours. But then when it comes to the systems, like you mentioned, you know, being thrown into the consulting world and having to sort of abide by the systems that have been put in place by those folks, it's a struggle, but I think it's a struggle everybody needs to go through to be able to come out of it as a better scientist or consultant, not necessarily a consultant, right? And I know when I first started working, and I only really started working with Ben Block and Ben Jessup, who was our former manager, and they had their systems in place. And the more I worked there, the more I started, you know, coming up with my own systems when I work on the projects that I'm working on. So when you're leading a project, you come up with your own systems, and then people, you know, give you some sort of feedback. Particularly, I'm just talking about data management, tracking who's doing what and what not. So it's tough. I would say, I don't know if I'm answering your question at all, but it's tough. It's not easy, but it's something I think everybody must go through. And I don't know if there's a way to necessarily prepare people for that. Once there's, at some point, you just have to jump.
So just tell them there will be a trial by fire.
Yes,
Okay.
exactly. Yeah, because every system is hard to, you know, get used to if you're not, you know, the exact person that is fit for that particular system.
Yeah, I would say like I think we had a pretty good like soft landing, and I think in that like our office was like just historically extremely well utilized, and we still are, so that's why we have so many damn projects, and maybe we should dial that back a bit, and that's maybe what we're gonna try to work on this next year as our own personal goals. But in that case, we haven't had to like just like immediately start, and there's no expectation at least at Tetra Tech to be like, oh, you just started, you have to find your own work. It's very much like now that we're established after 3, 4, 5 years is bringing in new work, and that's much easier when you've now kind of understood where the office kind of plays its role. But I would say, when you ask a question, I don't necessarily know if this is the exact same thing. But like, when I started, I remember like the first 3 months, I was like, oh my God, this is so intense. Because there'd be like random people that, because I was a new employee, they're like, and it was definitely during COVID, so it's just kind of all willy-nilly anyways. But I'd have people email me that are like colleagues in different offices and be like, hey, I have this presentation on Friday. Could you do all these analyses? And like, by the way, you only have like 8 hours to work on this project. And she's like, oh my God, I have to do all this work in 8 hours. And so the whole hours currency is really weird compared to academia. But like, at the same time, we've become way more efficient, and people ask, how can you like quantify it? How can you write a proposal? How long it'll take you to do this work? And it's like so much easier to know your own time. And so there's never a case where like it was maybe at the beginning, and there's very acute times where like we're running low on a budget and we have to be like very purposeful with it. But now it's like, okay, we know this project and we know kind of how to do it. We then use our best estimates to figure out how long it would actually take us to do it. And so we're never like at a point where we're constantly like hitting that like red line of not having hours to work on a project. But
Yeah,
that was something you could
yeah, and that question reminded me of something else too, which is this, I feel like in consulting, we constantly have this focus shifting exercise, because Ben's working on a few projects, so he can tell you how many exactly I'm working. Had a conversation with our manager the other day, I'm working on 14 different projects, so it's constant. Clients are emailing you, they want this and they want it now. Other managers are emailing you, they want this and they want it 5 minutes ago, so you're constantly shifting your focus. So I feel like we are constantly looking for these time efficiency and brain efficiency exercises that we can do, and these I don't know, ways in which we can focus on something for at least 2 or 3 hours, because at that point it becomes such privilege to be able to work on one thing for 4 hours and be interrupted. So we're working, but technically working from an office, but like we're trying to block off our time so people don't bother us. People will still bother you, it's consulting. People email, people send you messages on Teams. So that's one thing I find really challenging in this. And I'm so looking forward to not being this busy where I can focus only on a few projects on a weekly basis and not this many.
A question from online.
Sure.
Is it teaching R specifically, or would a more useful wink language like Python be good as well?
Yeah, I mean, yeah, it's not hard. You know how to code in Python, that's fine too. It's just,
But Python's not as good.
yeah,
Sorry.
yeah, I think there's definitely two camps. We have a bunch of people that know how to Python code and a bunch of people that know how to R code, and not a lot of people that do both. So it's basically, yeah, what language do you want to speak?
I'm gonna talk to those people.
So you guys talked about like the reports and the calm documents and stuff that you write, and you talked about the shiny apps, like the story maps. Do you guys also write papers and like publications, or do you mainly focus on these like specific outputs of your work?
Yeah, it's infrequent that a client wants to publish a paper. It's happened a lot with EPA, and like obviously you all are aware of like federal climate at this moment. So like
I was gonna ask about that too.
yeah,
So-
well, we can get to that. We can ask that next. But yeah, so like the EPA would, some of our other colleagues would historically publish a fair amount of the work that they would do, and that was oftentimes like climate change related or some other component to it. We did, I mean, technically the one that Kate and Ismar on the cover of is an EPA publication, so that went through peer review through EPA, but that was because EPA decided to move it from just our deliverable, and they then led it. So like, if you look at the actual like authorship, even though I was first author, now there's an EPA person as first author, which is totally fine. But like, infrequently, it's usually all white papers that are the deliverable at the end, where it's just like a summary of all the work or any sort of recommendations. So a lot of the stuff that at least I do is like policy recommendations at this point, and so those are memos, and at the end it's the final report.
Yeah. And make no mistake, EPA folks will often say, this is a great idea, you should publish this. And that's where it ends.
Yeah.
So we have good ideas, but they're publishable ideas too, publishable work too, but nobody's willing to pay for it. Mr. Tetratek typically isn't either, so.
Yeah, I mean, I think there's cases where it's like, the Massachusetts one, I would love to publish that since it's gonna be new methodology, but like the other ones, maybe the rivers one would be worthwhile. The like Long Island Sound one, maybe it's not as
Yeah.
exciting to publish. So I think it really depends. And so like Massachusetts was interested in publishing that one. So, but on to the flip side, there is no incentive to either. You get paid to do good work, you don't get paid to publish papers. And so your incentive shifts, and that was really refreshing too, because like basically we still get to go to conferences, but now we don't care. And we don't have any of the incentives, and we just get to go to learn about science, and like it's just like it's not in that realm anymore. So it's very,
Yeah.
at least for me, very refreshing, because you don't have to kind of play the game.
Yeah, and we still have to present them. but-
Yeah.
Yeah.
Which I think.
But yeah, that's fine. Yeah, conference have become a little more relaxing, I think.
Yeah. So Andy, you had a question about federal funding?
Oh, yeah, I was just gonna ask, like, you talked about the Clean Water Act and EPA kind of guiding what you would do. Were there any big changes, like with the federal EPA cuts and stuff recently? Or are you like able to fill, gaps that are forming with?
Yeah, I think that's been a huge thing, and that we're kind of alluding to with others, like if we had just solely been EPA funded, we would be like out of jobs basically, because EPA is really just kind of disappear. We supposedly have projects that are in the works, but like there have been people just got shuffled somewhere, or the one admin person got fired, and now they have a whole different department, and so it's like it's all a mess still, and so we're slowly getting progress on EPA stuff. But so that's why we've largely diversified to like states and tribes.
And the cities and towns and whatnot.
Yeah, and like Champlain Basin Program, and the Basin Program's obviously like the parent group is NUIPIC, and so we work directly with NUIPIC as well on like the Long Island Sound project, or we're working on a fish project with them in Long Island Sound again. And so I think like we've really tried to diversify ourselves, because I think prior to us starting, at least what our supervisors told us, was that like they were really concerned, like the last Trump administration, of being too over dependent on EPA. So it was really trying to focus and diversify, and to your point, like bringing different business lines to not just to have EPA projects.
But in EPA, we know people who know people who know people, so projects tend to still come from what are promised to us in whatever, in a few months, but we'll see if we believe them or not.
Yeah. Any other questions?
We're at 4:30, so call it at 4:30, but there's everyone in the room is on to this day, and we know there's quite a lot of snacks on the back table. Before we let you go, we just want to thank you for coming back to PBM as alumni. When the Alumni Association heard that we were doing this, they brought us a gift bags. And we have stuffed, we've stuffed our Resources Institute swag.
Nice, thank you.
Wow.
Thank you. Appreciate it.
Yeah, thanks for coming.
Yeah.